This protocol enables researchers to precisely heat a droplet interface bilayer, or DIB model membrane, which allows for studying a variety of temperature-related effects that occur in cellular environments.
The core advantage stems from the ability to locally measure and control bath temperature in a low-volume reservoir without obstructing access for the electrical or optical characterizations of the DIB.
The ability to precisely heat the fluid bath unlocks the possibility to study the transport and signaling properties in DIBs, formed from a much wider variety of membrane constituents, including natural cellular extracts.
This is a multi-step protocol leveraging multiple equipment that must be followed closely to achieve sufficient experimental accuracy. Thus, any ambiguity in the written process can be clarified via visual demonstration.
To begin, gather 2 pieces of 1 mm thick insulative rubber, trimmed to 25 by 40 mm in length, 2 pieces of a 6 mm thick rubber that are also 25 by 40 mm, a prepared aluminum base fixture assembly, and an acrylic oil reservoir that fits in the viewing window of the aluminum base fixture. Place the thinner rubber pieces onto the stage of the microscope such that the long edge of each piece is tangential to the stage opening. Position the aluminum base fixture on top of the insulative pads with the viewing window of the fixture centered above the objective lens. Place a thicker piece of rubber on top of each resistive heating element. Then, use a microscope stage clip to hold it in place to protect the heating elements from damage caused by the stage clips, and to insulate against accidental electrical shorting. Carefully bend the measurement end of a thermocouple.